Here it is given that x 17, 3x minus y square minus 2 and 3x plus y square minus 30 are four consecutive terms of an increasing arithmetic sequence, and we have to find the sum of these four terms. As these terms are in arithmetic progression, the difference between any two consecutive terms will be the same. It means 17 minus x will be equal to 3x plus y square minus 30 minus 3x minus y square minus 2, and from here we get 2y square plus x equals 45. Similarly, the difference between the first and last term will be equal to thrice the difference between the middle two terms. So from here we get 3x plus y minus 30 minus x equals 3 times of 3x minus y minus 2 minus 17. From here we get 4y square minus 7x equals minus 27. If we have a look at the two equations that we have got using the property of arithmetic progression, we can say that we can easily find the value of x and y square. However, we don't have to find value of y square, as the quantity that we have to compute, which is the sum of four numbers, will not contain y. So we just need to compute value of x. In the first equation, coefficient of y square is 2, and in second equation it is 4. So in order to eliminate y square, we need to multiply first equation by 2, and then we need to subtract it from second. After that we'll get the value of x as 13, and the quantity that we have to compute is x plus 17 plus 3x minus y square minus 2 plus 3x plus y square minus 30, which is equal to 7x minus 15, that is 7 into 13 minus 15. 91 minus 15, 76. So our required answer is 76. But we have to not just find the sum of these four numbers, but have to check which of the given options is a factor of 76. Out of the given four options, only 2 divide 76. Therefore our required answer is A. Here we have a quadrilateral PQRS, in which PQ is given as 5, QR as 17, RS as 5, and PS as 9, and we have to find the length of diagonal QS. Here we have two triangles PQS and QRS. We know that the sum of any two sides in a triangle is always greater than the third side, and the difference of any two sides is always less than the third side. So from here we get SQ less than 9 plus 5 considering triangle PQS, and so SQ is less than 14, and when we consider triangle QRS we get SQ less than 22. Obviously this is not of any use because we have already got SQ as less than 14, so we need to apply the second property wherein any side is greater than the difference of other two sides. From here we get SQ greater than 17 minus 5. From here we get SQ greater than 12. So SQ lies between 12 and 14 excluding both. Fine. So from here option B depicts this range. Therefore it is the correct answer. In this problem it is given that S is equal to alpha into omega upon tau plus eta into omega, where all the parameters are positive integers. If omega is increased and alpha, tau and eta are kept constant, then S. In such kind of expression like we have in present case, where one of the parameter, that is omega, is in numerator as well as in one of the term of denominator. In such cases, whenever the value of omega is increased, the value of this expression will increase irrespective of the other things like value of alpha, tau and eta, given that they are kept constant. And we can check it through couple of methods. First one is by taking numerical values of the given parameters, and second method to check it by checking the actual factor of multiplication in numerator and denominator. So let's take the first method where we take value of alpha as 1, tau as 2 and eta as 7. In this case the value of S comes out to be omega upon 2 plus 7 omega. Here it is asking to increase the value of omega. So let's suppose in first case value of omega is 1. In this case value of S will be 1 upon 9. When we increase omega from 1 to 2, we get the value of S as 2 upon 2 plus 7 into 2, which comes out to be 1 by 8. So from here it is apparent or obvious that when the value of omega is increased from 1 to 2, the value of S also increases from 1 by 9 to 1 by 8, and we can check it for other values of given parameters. And second method is by checking the multiplying factor in numerator and denominators. As we know that when we increase value of omega from any particular value to other values by some factor, let's say it is x, And if we want to keep the value of this quantity constant, then we need the same factor of x in denominator also, but it is present in only one of the term, which is eta into omega, but not in the other term. So effectively the increase in the value of numerator will always be greater in comparison to increase in the value of denominator in term of factor. Like if multiplying factor is x, like value of omega is increased from p to p plus x, then the value of numerator will go up by the factor of x, but the value of denominator will not go up by the same factor, as one of the term in denominator does not have omega as its multiplier. So from here it is obvious that whenever we have this kind of expression where one of the factor, like omega in the given case, is multiplied by something in numerator and it does not have any other term, and in denominator one of the term has omega as its multiplier but the other terms are independent of omega, and it is also known that all the parameters are positive, then the value of this whole expression will always increase when the value of omega or any other such factor increased. So from here option A comes out to be the correct answer. This problem, Professor Suman takes a quiz of num. In this problem, Professor Suman takes a number of quizzes for a course. All the quizzes are out of 100. A student can get a grade A in the course if the average of her scores is more than or equal to 90. So for getting grade A, one needs to score greater or equal to 90. Grade B is awarded to a student if the average of her scores is between 87 and 89, both included, which means for grade B, a student needs to score at least 7 and at most 89, and if the average is below 87, the student gets a grade C. So grade C is awarded when average is less than 87. Ramesh is preparing for the last quiz and he realizes that he must score a minimum of 97 to get an A grade. After the quiz, he realizes that he'll score 70 and he'll just manage B. So we have to find the number of quizzes taken by Professor Suman. As we know that Ramesh needed 97 marks to manage an average of 90 across the all tests, and after the test he realized that his score would be 70 and he would just manage grade B. For that we need an average of 87. So the difference of 27 marks causes difference of 3 in average, and this is obtained by dividing the difference of marks, which is 27, by the number of tests. Let's say it is n in this case, and this is equal to 3, and we have to find the value of n. From here we get n as 9. So in total Professor Suman took 9 tests which is option D. Here it is given that polynomial ax cube plus bx square plus cx plus d intersects x-axis at 1 and -1 and y-axis at 2, and we have to find the value of b. If we apply the three given conditions, we'll get three equations, and here we have four variables, so it's not possible to compute the value of all the variables in the given problem. However, we can compute a few variables out of these four, and as it cuts or polynomial cuts y-axis at 2, it means the value of x has to be 0 when y is equal to 2. So start with the third condition, when the graph or polynomial cuts y-axis at 2. So if polynomial is y equals ax cube plus bx square plus cx plus d, and when it cuts y-axis at 2, which means y equals 0 and x will be y equals 2 and x will be 0, in that case we get the value of d as 2. When it cuts x-axis at 1, which means y has to be 0, and from here we get 0 equals a 1 cube a, so b into 1 square, that is b. Similarly c plus 2, as we have got the value of d as 2. Now when x equals -1, again y will be 0. In that case 0 will be equal to a into -1 cube, which means minus a, plus b into 1 square, which means b. Similarly minus c plus 2. If we have a look at these two equations, then it becomes obvious that in the first equation a and c have positive coefficient, whereas in second equation they have negative coefficient. It means if we add these two equations, a and c will get cancelled out, and from where we will get the value of b. So add these two equations, we get 0 equals 2b plus 4. From here we get b equals -2. Therefore option A is the correct answer. In this problem it is given that mod of x plus 7 plus mod of x minus 8 is equal to 16, and we have to find the sum of all possible values of x. So first of all we have to find the different regions in which we have to find the value of x, as mod of x when equated to 0, we get x equals -7. Similarly when mod of x minus 8 is equal to 0, we get x equals 8. So we have got three different ranges in which we have to check the value of x. First one is when x is less than -7. Second one is when x is greater or equal to -7 but less than 8. And third is when x is greater or equal to 8. Let's come to the first case, when x is less than minus 7. In this case, mod of x plus 7 will be equal to minus x plus 7, and mod of x minus 8 will be equal to minus x minus 8, which is equal to 0. From here we get minus twice of x plus 1 equals 16. From here we get x equals minus 7 by 7.5, which is less than minus 7. So this is one of the acceptable values of x. Let's move to the second case when x is greater than minus 7 but less than 8. In this case, mod of x plus 7 will be x plus 7, and mod of x minus 8 will be minus x minus 8, which is equal to 16. From here we get 15 equals 16, which is not possible. So the value of x cannot lie in the range of minus 7 to 8. Now let's move to the last case when x is greater than 8, greater or equal to 8. In this case we get both mod of x plus 7 as x plus 7, which is with positive sign, and similarly mod of x minus 8 will be x minus 8 equals 16. From here we get x equals 8.5. So we have got two different possible values of x, and these are minus 7.5 and 8.5, and we have to find the sum of these two values. So the required sum is minus 7.5 plus 8.5, which comes out to be 1. Therefore option B is the correct answer. In this problem, it is given that there are two windows on the wall of a building that need repairs. A ladder 30 meter long is placed against the wall such that it just reaches the first window, which is 26 meter high. So it is something like this. 30 meter long ladder is placed against a wall such that it just reaches the first window. Let's say this is P, and height of P from ground is 26 meters. The foot of ladder is placed at A, which means this point is A. After the first window is fixed, the foot of ladder is pushed backwards to point B so that the ladder can reach the second window. The angle made by the ladder with the ground is reduced by half. It means if this angle is theta, then ladder is pushed in such a manner the angle now made by the ladder with the ground is theta by 2, and this point is Q, which is second window, and suppose foot of the wall is O. The distance between A and B is, we have to compute distance between A and B. Now, by using Pythagoras theorem in triangle POA, we can find the length of OA. So, OA square will be equal to PA square minus PO square, which is 30 square minus 26 square, and this is equal to 4 root 14. The value of this quantity will be approximately 15. Now we can find the value of theta. Cos theta will be base, which is 15, upon hypotenuse, which is 30. So from here theta will be 60 degree. It means theta by 2 will be 30 degree. So cos 30 will be equal to base, that is OB, upon hypotenuse, that is QB. From here it will be equal to root 3 by 2, as OQ is known to us, that is equal to 30. From here we get OB as 15 root 3, which will be approximately equals to 26. So from here AB will be equal to 26 minus 15, which is equal to 11. So the value of required quantity will be approximately equal to 11, which is in sync with option E. Therefore, it is the required answer. In this problem, it is given that Amitabh picks a random integer between 1 and 99, doubles it, and gives the result to Shashi. After this, Shashi gets a number from Amit. Each time Shashi gets a number from Amitabh, he adds 50 to the number and gives the result back to Amitabh, who doubles the number again. The first person whose result is more than 1000 loses the game. Let x be the smallest initial number that results in a win for Amitabh. The sum of the digits of x is, if initially Amitabh has x amount, x number with him, he doubles it and then gives it to Shashi, who adds 50. So the number with Shashi will be 2x. After that he adds 50 to it and gives back to Amitabh, who doubles it again. It means twice of 2x plus 50 will be 4x plus 100. This is the amount that Amitabh gives to Shashi in the second step. So the amount with Shashi after adding 50 in second step will be 4x plus 150, and this amount Shashi will give to Amitabh, who will double it again, so it will become 8x plus 300. So similarly we can find the amount with these two person in subsequent steps, and in fifth step we see that the amount with Amitabh is more than 1000, and we also know that Amitabh wins the game, so the game should come to an end in fourth step only with a win for Amitabh. It means 16x plus 750 has to be more than 1000. From here we get 16x greater or equal to 255 from here we get x greater or equal to 16. So the minimum amount that Amitabh needs to have initially has to be 16 in case he wins the game. So the required answer, that is the sum of digits of x, in this case is 1 plus 6, which is 7. Therefore option C is the correct answer. In this problem, some basic info is given and it is followed by two statements, and after that we have to answer a question. Here basic info is that x, y, x plus y, x minus y are four natural numbers, and we have to find or determine the sum of these four numbers. And for determining these four numbers, sum of these four numbers, we have got two statements. First statement states all four numbers are prime numbers, and as it can be seen that sum of two prime numbers is also a prime number, and we know that all the prime numbers except 2, which is the least prime number, are odd. So if x and y both are odd prime numbers, in that case x plus y, which will certainly be greater than x as well as y, is a would be an even number, which means it will not be a prime number. So from here it can be deduced that 1 out of x and y will have to be 2, and it can also be seen that x minus y, which is obviously a positive number, is a prime number. It means the value of y has to be less than the value of x. So from here 2 has to be the value of y, and it can also be seen that x minus y, x, x plus y are prime numbers where x is an odd number and y is 2. It means x minus y as well as y minus y, x plus y have to be odd, and there will be consecutive odd numbers because the value of y is 2, and there is only one triplet of consecutive odd numbers, that is prime numbers. So, and these three numbers are 5, 3 and 7. So from here we get the value of x as 5, and we already know the value of y. So from here we can compute the required sum, which comes out as 2 plus 3 plus 5 plus 7, which is equal to 17. So statement 1 is sufficient to determine whatever is asked there. Now let's move to second statement, as we have all sort of options like either statement 1 or statement 2 in option 5. So let's check what is given in statement second. In this statement it states the arithmetic mean of the numbers is greater than 4. It means x plus y plus x plus y plus x minus y upon 4 is greater than 4. From here it can be easily concluded that to get the value of this quantity greater than 4, we just need to choose value of x and y accordingly so that we get it more than 4, and there could be infinite number of values that we can have for x and y, and we would get whatever given in this statement. So this statement alone is not sufficient to give unique value of the asked sum. From here we can conclude that statement second is not sufficient to determine what is asked in the question. So only statement first is sufficient to determine the sum of four numbers. Therefore option A is the correct answer. In this problem it is given that ABC is a right angle triangle, D and E are midpoints of AB and BC respectively, and there are three statements on the basis of which we have to check which of the statement or a combination of statements is sufficient to determine the length of AC. First of all, we need to understand here we do not know which of the given 3 points contain contains right angle. So first of all, to determine anything we need to specify the position of right angle. So from here it becomes obvious that unless we know this point it is not possible to compute the length of AC. So third statement is must in order to determine the length of AC. So once we know this much of info, B, E, C, but again by this time we do not have length of any of the sides of the triangle, so we need other info as well. So if we go by either statement E or second, we get the same kind of info. Let's consider first statement. It is D, it is E as per the given info. In first statement it is given that AE is 19 centimeter, which means this is given as 19 centimeters. Again, if we have just the length of AE, it's not possible to compute length of AC. So let's consider second statement as well, according to which the length of CD is 22 centimeter. So now let's try to find out whether it is possible to find length of AC or not. In triangle ABE, using Pythagoras theorem, we get AB square plus BE square equals 19 square. AB square plus B is half of BC, as E is the midpoint of BC. So from here BE square can be written as BC upon 2 whole square equals 19 square. From here we get 4AB square plus BC square equals 4 into 19 square. Similarly, using the Pythagoras theorem in triangle BCD, we get 4BC square plus AB square equals 4 into 22 square. Now when we add these two equations, we get 5AB square plus 5BC square equals 4 into 22 square plus 19 square, and 5 AB square plus BC square can be written as AC square using Pythagoras theorem in the given triangle. So from here we get 5AC square equals 4 into 22 square plus 19 square. From this equation it's obvious that we can compute value of AC, though we do not need exact value of it. So to answer this question we need all the three statements. Therefore our answer would be option E. In this problem we have two circles C1 and C2 with radii 3 cm, 3 unit and 8 units respectively. The common internal tangent T touches the circles at points P1 and P2 respectively, which means tangent T1 touches C1 at P1 and C2 at P2. The line joining the centers of the circle intersects T1 at X. Let O1 be the center of C1 and O2 be the center of C2, and O1 A2 intersect T at point X. The distance of X from the center of a smaller circle is 5 units, which means O1X is 5 units. What is the length of line segment P1 P2? We have to find the length of P1 P2. O1 P1 is 3 and O2 P2 is 8. O1 P1 will be perpendicular to P1 P2 as it is the line drawn from the center to the tangent. Similarly, O2 P2 will be perpendicular to P1 P2. Now we have two right angle triangles, and these are O1 P1 X and O2 P2 X. In triangle O1 P1 X, using Pythagoras theorem we can find the value of P1 X, which will be 4. Now in order to find the value of P1 P2 we have to calculate value of P2X, and it can be noted that these two triangles are similar triangle as one of their angles are right angles and their opposite angles at vertex A are equal. So the ratio of corresponding sides should also be equal. From here P2X upon P1X will be equal to O2 P2 upon O1 P1. From here we get P2X as P1X, which is 4, O2 P2 that is 8 upon O1 P1 3. From here we get the value of P2X as 10.67. Therefore P1 P2 will be 4, that is P1X, and 10.67 which is P2X. So the value of P1 P2 is 14.67, and this value lies in the range of greater than 14 and less or equal to 15. Therefore option C is the correct answer. In this problem it is given that the probability that a fact randomly chosen positive divisor of 10 raised to power 29 is an integral multiple of 10 raised to power 23 is a square upon b square, and we have to find the value of b minus a. So first of all find the number of factors of 10 raised to power 29, which can be written as 2 raised to power 29 into 5 raised to power 29. So the number of factors of 10 raised to power 29 will be 29 plus 1 into 29 plus 1. which is equal to 30 into 30. Now we have to find the number of factors of 10 raised to power 29 that are multiple of 10 raised to power 23. So 10 raised to power 29 can be written as 10 raised to power 23 into 10 raised to power 6. So all the factors of 10 raised to power 6 will give those factors of 10 raised to power 29 that are multiple of 10 raised to power 23. So let's find the number of factors of 10 raised to power 6, which will be nothing but 10 6 plus 1 into 6 plus 1, that is 7 into 7, as it is given that the probability that a chosen positive divisor of 10 raised to power 29 is an integer multiple of 10 raised to power 23 is a square upon b square, which means a square upon b square is nothing but 7 into 7 upon 30 into 30. From here we get a equals 7 and b equals 30. Therefore the required difference will be 30 into 7, that is 23. Therefore option D is the correct answer. Circle C1 has a radius of 3 units. The line segment PQ is the only diameter of the circle which is parallel to x-axis. So figure would look like this. PQ is a line parallel to x-axis. Therefore the y coordinates of these 2 points should be the same, but their x coordinate will be different. So let their x coordinates be x1 and x2 and the y coordinate be y, and we know that PQ is the diameter, so PQ will be equal to x2 minus x1, and this will be twice of the radius of the circle, so 2 into 3, that is 6. It is also known that P and Q are points on curves given by equation y equals ax and y equals twice of ax. So at point P, y will be ax1, and at Q, y will be 2ax2, and these 2 points have the same y coordinates. Therefore ax1 or a raised to power x1 will be equal to 2 a raised to power x2. From here we get 1 by 2 equals a raised to power x2 minus x1, which will be equal to a raised to power 6. So from here a will be equal to 6th root of 1 by 2, which is option E. There are two circles S1 and S2 with areas 8 and 9 units respectively. S1 is inscribed within S2 with one corner of S1 on each side of S2. So let's draw the figure. This is S2, that is outer square, and this is S1 inscribed within S2. As we know that area of S2 is 9 units, which means its sides will be 3 units, and that of S1 is 8 units. It means side of S1 will be square root of 8, that is 2 root 2 units. The corners of smaller square divides the sides of the bigger square into two segments one of length A and the other of length B, where B is greater than A, which means if this portion is B, then it will be A and it will be A, and so on. So from here we have A plus B equals 3, and A square plus B square will be a square of 2 root 2, which means 8. Now substituting value of A in term of B from first equation to the second equation, we get B minus 3 minus B whole square plus B square equals 8, which on simplification gives B equals 3 plus minus root 7 upon 2. From here we get B equals as 2.82 or 0.18. 0.18 will not be a possible value of B because B is more than A and the sum of these two numbers is 3. So the possible value of B is 2.82. Therefore value of A will be 3 minus B, which is 3 minus 2.82, that is 0.18. Therefore the ratio of B by A will be equals to 2.82 upon 0.18, which is approximately equal to 15.7, and this quantity lies between the range given in option D, which is greater or equal to 14 but less than 17. Therefore option D is the correct answer. Here diameter of the base of a water filled inverted cone like this is 26 centimeter, which means the radius of the cone is 13 centimeter. A cylindrical pipe 5 centimeter in radius is attached to the surface of the cone at a point. Suppose pipe is attached to this point to cylinder. The perpendicular distance between the point and the base, that is top, is 15 centimeter, which means this distance is 15 centimeter. The distance from the edge of the base to the point is 17 centimeter. This is given as 17 centimeter. The distance from the edge of the base to point is 17 centimeter along the surface. If water flows at the rate of 10 meter per minute through the pipe, how much time would elapse before water stops coming out of the pipe? So basically we have to find volume of this part of cylinder, that a cone, which can be treated as frustum. So if these points are marked as x, y, z, w, then x, y will be equal to xz minus yz, and yz can easily be computed as wz is 17 and yw is 15. So this will be under root 17 square minus 15 square, which is equal to 8. So from here we get the lower radius of the lower part of frustum as xy, which is 13 minus 8, that is 5 centimeter. Now we have height as well as base radius and top radius of the frustum. So we can calculate its volume as pi h by 3, where h is the height of frustum, r square radius of upper surface plus small r radius of the lower surface into capital R plus small r square. From here we get 22 by 7 into 15 by 3 plus 13 square plus 5 into 13 plus 5 square. On simplification we get 4070 centimeter cube. Now we have to find the rate of flow of water through the pipe in order to calculate the required quantity. It will be pi r square into rate of flow of water through the pipe, which is 10 meter in the given problem. So rate of flow of water is 22 by 7 into r, radius is 5 millimeter, when converted to centimeter will be 5 by 10 square into rate, which is 5, which is 10 meter per minute. So in term of centimeter it will be 10 into 100, and on simplification this quantity will comes out as 5, so 785.7 centimeter square upon cube upon minute. So the required time will be volume of frustum upon the rate of flow of water through the pipe, and it will be 4070 upon 785.7. This is approximately equal to 5.2 minute, which lies in the range of greater than 5 and less than 5.2. Aditya has a total of 18 red and blue balls in 2 bags. Each bag has marbles of both color. Let the bags be B1 and B2, and the number of balls in bag B1 be X. Therefore the number of balls in bag B2 be 18 minus X. and each of these two bags has at least one and at least one red and one blue ball. Let the number of red ball in these two bags be A and C, and blue balls be B and D respectively. Now, a marble is randomly drawn from the first bag followed by another randomly drawn from the second bag. The probability of both being red is 5 by 16. What is the probability that both marble being blue? Here it is given that probability of both the marble drawn from one from each bag is 5 by 16, which means A by X. This is the probability of a ball drawn from first bag being red, and C by 18 minus X is the probability of a ball drawn from bag B2 being red, and the probability of both these balls drawn from the two bags will be E upon X into C upon 18 minus X. It is given as 5 by 16. So from here we get A cross C upon X into 18 minus X equals 5 by 16. Now suppose A into X is equal to 5y and X into 18 minus X is 16y, where y is a constant. One thing can also be noted that the value of X has to be more than 2 and less or equal to 16. Similarly, the value of 18 minus X will also be greater or equal to 2 and less or equal to 16. And we have X plus 18 minus X equals 18. As the sum of two positive quantity is given, we can find the maximum possible value of X into 18 minus X, and this will realize when both these quantities are equal, that is 9 into 9, 81. So the maximum possible value of X into 18 minus X can be 81, from where we can say that the value of Y has to be less or equal to 5, as 16y is less or equal to 81. So from here, by putting the possible values of y, which could be 5, 4, 3, 2, 1, we can find possible values of x, and we get the only possible value of x when y is 5 and x comes out to be 10. In that case, 18 minus x will be 8. From this we can find the value of A and C as well, because now it is equal to 25 and the value of each of these two quantity is less than 18. Therefore A will be 5 and C will also be 5. From there we get B equals 5 and D equals 3. As we have to find both the marbles being blue, so in case of blue, first bag has 5 blue marbles and 10 total marbles, and second bag has 3 blue marbles and 8 total marbles. Therefore, the probability of a ball drawn from first bag being blue is 5 by 8, and from the second bag is 3 by 8, and both of the drawn ball being blue will be 5 by 8, 10 into 3 by 8, and this will be equal to 3 by 16, which is option C. In the diagram given below, ABCD is a rectangle of area 90 units. The points P and Q trisect AB, which means AP equals PQ equals QB, and R bisects CD, which means DR is equal to RC. The diagonal AC intersects the line segment PR and QR at M and N respectively. This is point M, which is point of intersection of line AC and PR, and point N is point of intersection of QR and AC, and we have to find the area of quadrilateral PQMN. So let AB equals 6x and BC equals y. From there we get AP as 2x, QB as 2x, and PQ as 2x, DR as 3x, and EB BC as y. Here T1 T2 is a line parallel to AB and it bisects AB, AD and BC, and LR is the line which is again bisects AB and DC. VGVU is the line perpendicular to T1 T2 and passes through M. Similarly, ZS is a line perpendicular to DC, passes through N. As we know that the area of rectangle ABCD is 90 degree, which sides are 6x and y. Therefore 6x into y is equal to 90. From here we get x y as 15, and it can also be noted that triangle PQR is similar to triangle GHR, and we know that T1 T2 is the midpoint of AD or BC. So from here we get UH as half of PQ. PQ is 2x, which means GS will be x, and from there GE will be x by 2. Now we can compute the area of trapezium PQHU. Therefore area of trapezium PQHU HZ 1 by 2 sum of parallel sides PQ, which is 2x, and GH, which is x, into perpendicular distance between them, it is y by 2. This is equal to 3xy upon 4, 3 into 15, as the value of xy is 15 upon 4. From here we get area of trapezium PQSG as 11.25. Now in order to find the area of quadrilateral PQ and M, we have to find area of triangle MGE and that of EHN. It can be observed that triangle APM is similar to triangle MGE, and from here we get UM upon VM equals GE upon AP. GE is x by 2 and AP is 2x. From here we get UM upon VM as 1 by 4. This implies that UM is equal to VM, sorry, UV upon 5, and this will be equal to y by 10 as UV is y by 2. From here the area of triangle MGE will be 1 by 2 into GE, which is x by 2, into UV, which is y by 10, and after substituting value of x, y, we get the area of triangle MGE as 0.375. Similarly, we can find the area of triangle EHN, which is equal to 0.27. From here the area of quadrilateral PQNM comes out to be the area of trapezium PQSU, which is 11.25, minus area of triangle MGE, which is 0.375, plus the area of triangle EHN, which is 0.27. This is equal to 11.14, which lies in the range of greater than 11 and less or equal to 15, which is option D. Here we have two numbers, 297B and 792B. Both are in base system B, and it is known that the first number is a factor of the second number, and we have to find the value of B, as first number is a factor of the second number, which means second number is obtained by multiplying first number by some natural number. From here we get k equals 7b square plus 2b plus 9 upon 2b square plus 9b plus 7. As we have to find value of b, and the values given in options are the value which, when substituted in the given equation, should give an integral value of k. So our answer will be that option in which the given figure on substituting for b will give an integral value of k. On checking the option, we find that when b is 19 we get an integral value of k which is equal to 3. Therefore our answer is 19. A teacher noticed a strange distribution of marks in the exam. There were only three distinct scores: 6, 8 and 20. The mode of distribution was 8, which means the maximum number of students scored 8. The sum of scores of all the students was 504, which means if X student scored 6 marks, Y student scored 8 marks, and Z student scored 20 marks, then 6x plus 8y plus 20z is equal to 504. And it is also given that the number of students in most populated category, which means y, because the maximum number of students who scored a particular score was y, was equal to the sum of the number of students with lowest score, which is x, and twice the number of students with highest score, which means twice of z. So we have two equations and three variables, and all the variables in these two equations are natural numbers. So substitute the value of y in equation first from second. After this we get 6x plus 2x plus 2z plus 20z equals 504, and on simplification we get 7x plus 18z equals 252. Here both x and z are natural numbers, so we need to find the possible ordered pair of x and z with the help of this equation. And on checking we find that there is only one ordered pair for x and z, wherein x is 18 and z is 7, and now we have to find value of y, which is x, that is 18 plus 2z, 2 into 7, which means 14. Therefore value of y comes out to be 32, and we have to find the total number of students in the class. So the total number of students in the class is x plus y plus z, which is 18 plus 7 plus 32, that is 57. Therefore option E is the correct answer. In this problem it is given that mod of x plus 7 plus mod of x minus 8 is equal to 16, and we have to find the sum of all possible values of x. So first of all we have to find the different regions in which we have to find the value of x. As mod of x when equated to 0, we get x equals minus 7. Similarly, when mod of x minus 8 is equal to 0, we get x equals 8. So we have got three different ranges in which we have to check the value of x. First one is when x is less than minus 7. Second one is when x is greater or equal to minus 7 but less than 8. And third is when x is greater or equal to 8. Let's come to the first case. When x is less than minus 7, in this case mod of x plus 7 will be equal to minus x plus 7, and mod of x minus 8 will be equal to minus x minus 8, which is equal to 0. From here we get minus twice of x plus 1 equals 16. From here we get x equals minus 7 by 7.5, which is less than minus 7. So this is one of the acceptable values of x. Let's move to the second case when x is greater than minus 7 but less than 8. In this case, mod of x plus 7 will be x plus 7, and mod of x minus 8 will be minus x minus 8, which is equal to 16. From here we get 15 equals 16, which is not possible. So the value of x cannot lie in the range of minus 7 to 8. Now let's move to the last case when x is greater than 8, greater or equal to 8. In this case we get both mod of x plus 7 as x plus 7, which is with positive sign, and similarly mod of x minus 8 will be x minus 8 equals 16. From here we get x equals 8.5. So we have got two different possible values of x, and these are minus 7.5 and 8.5, and we have to find the sum of these two values. So the required sum is minus 7.5 plus 8.5, which comes out to be 1. Therefore option B is the correct answer. Here it is given that a rectangular swimming pool is 48-meter long and 20-meter wide. The shallow edge of the pool is 1 meter deep. For every 2.6 meter that one walks up the inclined base of the swimming pool, one gains an elevation of 1 meter. What is the volume of water in the swimming pool? Assume that the pool is filled up to the brim. The cross-sectional view of the pool would look like as shown in the diagram. As it is known that for every 2 meter that one walks up the inclined base of the swimming pool, one gains an elevation of 1 meter. If angle CDE is equal to theta, then sine theta will be 1 upon 2.6, which is equal to 5 by 13. From here we get tan theta as 5 by 12, and also we know that tan theta is equal to 40 y upon 48, which is equal to 5 by 13. From here we get y as 20. Volume of the pool will be area of the cross section into width of the pool. Area of the cross section is 1 by 2 into 48 into 20 plus 48 into 1, and the width of the pool is 20. This comes out to be 10,560 cubic meters. This is option D. In this problem, we have to evaluate the value of summation 1 upon log 100 factorial to base I, where I is from 2 to 100. This is equal to 1 upon log I to base 100, where I is from 2 to 100. As we know that log a to base b is equal to 1 upon log b to base e. Now on further simplification, we get log I to base factorial 100, where I is from 2 to 100. On expansion, we get log 2 to base factorial 100 plus log 3 to base factorial 100 plus and so on, plus log 100 to base factorial 100. We know that log a plus log b plus log c and so on is equal to log a into b into c and so on. Using this property, we get log 2 into 3 into 4 into 5 and so on till 100 to base factorial 100, and this will be equal to log 100 factorial to base 100 factorial, and it will be equal to 1. Therefore, the value of required expression is 1. This is option C. The graph of this problem is shown on the next slide. So after reading whatever written as a basic info, I'll explain everything through the graph. Here it is given that left side of x-axis represents countries that are poor and right side of x-axis represents countries that are rich. For each region, GDP is based on purchasing power parity. These are World Bank estimates. So it can be noted that from the graph there are 8 different regions, and for each region there are 2 parameters. First one is GDP, and as it is already mentioned that on left side of x-axis or horizontal axis, poorer countries are represented, and on right side richer countries are represented. It can also be seen that vertical axis or y-axis represents polity score. It is 0 for authoritarianism, where there is no democracy, and 20 for full democracy. And we can check these two parameters for Africa, like the score of polity for Africa is lowest. For poorer countries it is slightly more than 10, and for richer countries it is slightly more than 12. And in the similar way, we can observe score of polity for Asian Pacific region as well. It is slightly more than 13 for poorer countries or poorest country, and it is around 16 or 17 for richer countries. Similarly, we can see these two parameters for all the 8 regions. And one thing should also be noted that GDP is given in term of log. So whenever we need to do any calculation related to GDP and all, we have to take care of this thing. Now we have understood what the graph is all about. So let's take the question. In the first question of this set, it is asking which of the following could be the correct ascending order of democratic regions for poor. So we have to not check the order of all the 8 countries according to democracy prevalent in them for poor. Rather, we have to check options, as it can be seen that none of the option has all the 8 regions. So here we have to check ascendancy or ascending order of democratic region for poor as per the given options, not for the given graph or 8 regions. And after having a look at the graph, it can be seen that the least democratic region for poor is CNE Europe, where the polity score for poor or poorest people is slightly lesser than 5, and the same thing for Middle East is slightly or in fact equal to 5. So the least democratic region for poor among the 8 given regions is CNE, and the second least is Middle East. Similarly, we can find the third least and so on. So let's have a look at option. If we observe options closely, then we can see that in first 3 options, Middle East is shown as more democratic for poor compared to other regions by at least 3 to 4 regions, which is not true, as we have already discussed. Middle East is the second least democratic region for poor, but here in first 3 options it is shown that it is not the second least but more than that. So first 3 options are ruled out, they cannot be answered as they are not representing the correct order. So we have got rid of first 3 options. Now we have to check the last 2 options. On observation, we find that North America is the lesser democratic for poor compared to Western Europe. So option E is also not possible because it is not representing correct order. Now we are left with option D, and it has to be our answer, and we can check this from the graph whether given order is true or not. And on observation we find the order of given regions is correct for option D. Let's move to the next question. Here it is asking which region has the highest disparity of democratic participation between rich and poor. For this question we don't need to do any calculation or estimation, just we have to look at graph and see which region depicts maximum disparity for democratic participation between rich and poor. From the graph it becomes obvious that the answer has to be CNE Europe, as the polity score for poor in this region is less than 5, but for rich it is around 20, which is the maximum. So and so the difference here is of 15, and this kind of difference cannot be found in any other 7 regions. So CNE Europe is the country where the difference or disparity of democratic participation between rich and poor is the highest. Therefore B is the correct answer. Move to the last question of this set. The maximum GDP of African region is higher than the maximum GDP of South American region by a factor of. So for this problem, first of all, we need to find the maximum GDP for Africa, which is slightly more than 9.5. It is around 9.6, and the maximum figure for South America is slightly lesser than 9.5. This is 9.4. So the difference between the GDP in term of log of these two countries is zero point 0.2. So if difference is considered x, then log x is zero point 0.2. From here, the value of x is 10 raised to power zero point 0.2, which is approximately equal to 1.6. So the maximum GDP of African region is 1.6 higher than the maximum GDP of South African region, and none of the first four options contain this figure. Therefore, option E is the correct answer. In this set, the given table gives information about some parameters related to tourism. First column in the table shows years, and second column foreign tourist arrivals in India in millions. So we can find the number of tourists who came to India in any of the years from 1997 to 2011. This figure in 2001 was 2.54. Next column shows foreign exchange earnings from tourism in India in US dollar. The figure for 2001 is $3,198 million, and next column shows foreign exchange earnings from tourism in India in rupees crore. So simply this column gives not any additional information, just the figure in term of rupees instead of dollar. And now coming to the next column, it gives information about the number of nationals, Indian nationals departures from India, and the figure for 2001 is 4.56. And the last column gives information about number of domestic tourists visits to all states or UTs in millions. The figure for 2001 is 236.47 millions. So given information quite easy to understand. Now coming to questions. In the first question, it is asking when in which of the following years the percentage increase in the number of Indians going abroad was greater than the percentage increase in the number of domestic tourists. Number of Indians going abroad is given in the second last column from right hand side, and the number of domestic tourists is given in the last column from the right side. So one more thing we need to observe with the help of options, we have to find the given parameter for the years given in options. By observation, we can see that there are 5 different years in which we have to check the given parameter, and these years are 2004, 5, 6, 7 and 8. Now Coming to year 2004, number of Indian nationals increases in 2004 compared to 2003 from 5 5.35 million to 6.21. So there is increase of approximately 16%, and when the same increase is observed for number of domestic tourists, it comes out to be around 18.5%. So in 2004, the percentage increase in number of Indians going abroad is lesser than that the percentage increase in the number of domestic tourists. Similarly, we can check for other years like 2005, 6, 7 and 8, and we find that only in 2005 and 2007 the percentage increase in the number of Indians going abroad is more than the percentage increase in the number of domestic tourists, and these two years are present in option C. Therefore, option C is the correct answer. In the next question, it is asking in which of the following years was the rupee cheapest with respect to dollar. Again, we have to check only those years which are given among options, and these years are 2001, 2002, 2007, 2010 and 2011. Here we don't need to do anything, just we need to find the value of ratio of figure figures given for the given years in column for foreign exchange earning from India in term of rupees to that of foreign exchange earnings from tourism in India in dollar, and these ratios are for the given years in the given order: 15,083 upon 3,198. For 2002 the same figure is 15,064 upon 3,103. For year 2007 the figure is 44,360 upon 10,792. For year 2010 the figure is 64,889 upon 14,193, and for year 2011 it is 77,591 upon 16,564. We don't need to compute exact value of these ratios, just we need to figure out approximate values of these ratios. The value of the ratio for the year 2001 is slightly less than 5. It is around 4.8, and for year 2002 it is certainly more than that in 2001, but for the other years the figure is less than 4.8. So the required year, or the year in which the rupee was cheapest with respect to dollar, is 2002. Now come to the last question. In this problem, R is defined as the ratio of foreign exchange earning from tourism in India in US $1 million to foreign tourist arrivals in India. Assume that R increases linearly over the years. If we draw a pie chart of R for all the years, the angle subtended by biggest sector in pie chart would approximately be. So basically we have to find value of R for all the given 14 15 years, and then we have to draw a pie chart, and then we need to check what is the angle subtended by the maximum value of R. One thing is quite clear, this is not the problem, that this is a problem that should have been left while attempting exam, because here we need to compute 15 figures, and after that we need to add these figures, and then in order to find the answer we need to divide the maximum value of R by the sum that we have got by adding all the 15 figures and multiply it up and multiplying it by 360. So this is not the problem that one should go for, because it's not possible to get answer of this problem in less than 7 to 8 minutes. And if we have look at options are quite close, so approximation is also not that easy in this problem. But let's see what answer comes out in this problem. The value of R for year 1997 is 1218.99. Similarly, it is calculated for all the years, and the sum of these values comes out to be 26,419.46. And it can also be seen that the value of R was maximum in 2011, and it was 2633.39. So we have to check 33 2633.39 is what fraction of 26,419.46. And as we have to find angles subtended by this fraction when a pie chart is drawn for the value of R, we need to multiply this fraction by 360. Here the exhibit given below compares countries first column on different economic indicators in first row from 2000 to 2010. A bar represents data for 1 year and a missing bar indicates missing data. Within an indicator, all countries have same scale. So first of all we need to understand what is meant by a bar represents data for 1 year and a missing bar indicates missing data. Like if we see Brazil's GDP in 2000 in US dollar, it is represented by some bar. Of course, it is not possible to find the value of this bar. We can just compare GDP of 1 year with respect to other years, and we can do the same for other parameters like services value added as a percentage of GDP, industry, agriculture, military, and so on. Missing data can be seen from military expenditure of Vietnam. In some of the years, there is no bar. It means this portion indicates missing data, and with the help of the given figure, we can compare expenditure or GDP of a country for different years, but we cannot find the exact percentage or exact figure. Let's come to the table. It is given that the table shows GDP of given countries during the period 2000 to 2010 in US billion dollar. We can see GDP of China in 2002 as 1416 billions. So that's what we needed to know about chart and table. Now come to the questions. Which of the following countries after United States has the highest spending on military as percentage of GDP in the period 2000 to 2010? From the graph, it is clear that United States spent maximum percentage of its GDP on military during the given period, and we have to find the country which spent maximum percentage of GDP on military expenditure after USA. From the column of military expenditure, it is pretty obvious that India is the country that spent maximum as a percentage of GDP on its military expenditure during the given period, as bar for India are larger than bar for any other countries except United States. So the answer of this problem is India, which is option C. In next problem, it is asked which country has witnessed maximum year-on-year decline in industry as a percentage of GDP, given that maximum value of industry as a percentage of GDP is 49.7%, which means no country spent more than 49.7% of their GDP on industry, and it was not less than 20.02% for any of the country. So we have to find year on year decline in industry as a percentage of GDP for the country that witnessed the maximum decline, and we need to check this for the given 5 countries during the given period. So let's consider first option. In first option, it states United States in 2002 to 3 that that is the bar for industry in 2002, and this is the bar for industry in 2003. By and large, it is stagnant. So United States could not be the country that witnessed maximum year-on-year decline in industry. So let's move to the next option. Brazil in 2006 and 7. Brazil in 2006 and 7, instead of witnessing decline, it witnessed growth in its industry. So again, this could not be the answer. Now come to the third option. India in 2009 to 10. Yes, India witnessed some decline in its industry from 2009 to 2008 to 9. So India could be a probable answer, but before zero in on India, let's check other options. Malaysia in 2008 to 9. In case of Malaysia, decline is more than that of India, which can easily be seen from the bars. Now come to the last option, China in 2008 and 9. China also witnessed decline from 2008 to 9, but it is quite insignificant compared to that was witnessed by Malaysia. So from the bar, it becomes obvious Malaysia is the country that witnessed maximum decline in industry on year to year basis. So Malaysia is the answer of this question, and this event was witnessed in 2000 from 2008 to 9. Therefore, option D is the correct answer. Come to the last question of this set. Which of the following countries has shown maximum increase in the services value added as percentage of GDP from year 2000 to 2010? Again, we have got four options to check the given parameter. Services, and we have to find which country witnessed maximum increase in services from 2000 to 2010. First option is Brazil. From the chart, it can be seen that the services witnessed almost no increase for Brazil from 2000 to 2010, as it is almost stagnant. And coming to next option, India. In case of India, it is quite significant, so it could be a probable answer. Now come to the third option, it is United States. In case of United States, it witnessed some increase, but it is quite less compared to that in the case of India. Now come to the next option, Philippines. In case of Philippines also witnessed increase in its services, but it is not as much as compared to India. So from the graph, it is obvious India is the country that witnessed maximum percentage increase in its services. Therefore, India is the answer of this problem, which is option B.